is the third planet from the Sun and also the largest rocky planet in the solar system. Viewed from space, Earth has an imperfect spherical shape, bulging at the equator and flattened at the poles. But that's just the external shape. The internal structure is much more complex. It resembles an onion with many layers wrapping around each other. The deeper you go into Earth's core, the higher the temperature rises. Scientists believe the temperature at the innermost core is about 10,000 degrees Celsius, nearly double the surface temperature of the Sun. After billions of years since formation, the temperature here remains unchanged. Earth's core remains hotter than the Sun. What would happen if Earth didn't have such a molten core? Have the answer yet, today. Wishing you relaxing and informative moments. Now, let's explore together. If doctors use ultrasound techniques to create images of internal body structures using ultrasound waves, then scientists use similar techniques to image Earth's internal structure. But instead of ultrasound, geologists use a similar technique to image Earth's internal structure. But instead of ultrasound, geologists use seismic waves, a type of sound wave generated by earthquakes. On Earth's surface, you can see with the naked eye, but the inner layers are revealed through seismic data. After many years of studying seismic waves, scientists conclude Earth has 5 main layers. The outermost layer is the crust, primarily composed of hard rock, with thickness from about 1.6 kilometers under ocean floors to 150 kilometers on high continental shelves. Below the crust are the upper and lower mantle, also called the mantle layer. This is a very thick layer, about 2,900 kilometers, accounting for 70% of Earth's volume, mainly in solid form and lying above the iron-rich core. Beneath the 2 mantle layers is the outer core, about 2,260 kilometers thick, containing mainly liquid iron and nickel. Finally is the inner core, considered Earth's center, spherical in shape with a radius of about 1,220 kilometers. This area contains mainly iron, along with small amounts of nickel and other elements. One fact is that the deeper inside Earth you go, the higher the temperature. When descending about 100 kilometers deep, the temperature reaches about 1,300 degrees Celsius. If going to the boundary between the mantle and outer core, at about 2,900 kilometers depth, the temperature increases to about 2,700 degrees Celsius, and if reaching the boundary between inner and outer core, the temperature is about 6,000 degrees Celsius. Hotter than the Sun. But this isn't the hottest area of Earth yet. The hottest place is believed to be at Earth's center, the innermost part of the inner core. Scientists estimate the temperature here reaches about 10,000 degrees Celsius. At this temperature, most metals would sublime, meaning they turn into gaseous state. Deep inside Earth and under extreme pressure, they. So why is Earth's core so hot? Of course, it doesn't come from the Sun, while the Sun warms us and all living things on Earth's surface. Sunlight cannot penetrate thousands of kilometers into the planet's interior. Instead, there are 2 heat sources generating the tremendous heat in Earth's core. The first heat source is the heat Earth inherited from its formation from the solar nebula. As you know, about 4.5 billion years ago, Earth formed from a giant gas cloud. With countless collisions and mergers of rock fragments and debris called planetesimals. This process lasted tens of millions of years, generating enormous heat sufficient to melt the entire Earth. At that time, our planet was heated beyond the melting point of iron. Heavy metal droplets were drawn toward the planet's center, gradually forming the molten iron core. Meanwhile, lighter elements floated to the surface, forming the later mantle and crust layers. Although some heat escaped into space, the remainder was trapped inside Earth and persists to this day. The second heat source comes from the decay of radioactive isotopes distributed throughout Earth. To understand this, imagine an element as a family with isotopes as members. The radioactive isotopes that keep Earth. There are 4 radioactive isotopes that keep the Earth's interior hot: potassium-40, thorium-232, uranium-235, and uranium-238. One of the names you might be familiar with is uranium-235, commonly used as fuel in nuclear power plants. Although most of the original uranium-235 and potassium-40 have disappeared, the Earth still has enough thorium-232 and uranium-238 to last for billions of years. Earth's core has remained hotter than the Sun. Scientists say that the molten core of the Earth plays a crucial role in generating the magnetic field and retaining the planet's heat, creating conditions for life to develop. The movement of the molten metal in the outer core generates the Earth's magnetic field, protecting us from harmful radiation from space. This is considered an invisible shield that protects life on Earth. So, what would happen if the Earth had no molten core? In reality, planets without a molten core can still exist. This occurs when iron is oxidized and trapped in silica mineral crystals or the planet's mantle. In this case, iron does not form a core, and the planet exists without a molten iron sphere at its center. If that happened to Earth, the planet's magnetic field would be lost. As a result, life on Earth would be directly exposed to harmful radiation from space and the Sun. At that point, solar storms would sweep across Earth, destroying the technologies humanity has built. Over time, Earth's atmosphere would also be lost. It is very likely that our Earth would become a second Mars. Scientists say that Mars once had a magnetic field, but it did not last long. Earth's core froze about 4.2 billion years ago, which significantly weakened the planet. Intense solar winds mercilessly blew away the atmosphere as they struck the planet at speeds of approximately 800 kilometers per second. Now, can you imagine what would happen to Earth if our planet had no molten iron core? According to a recent study by scientists, they believe the iron core inside Earth may be slowing down relative to the rest of the planet. This raises concerns about a catastrophic event for Earth. Researchers from Peking University in China examined seismic wave measurements passing through Earth from nearly identical earthquakes since the 1960s. The study found that the planet's inner core had been rotating slightly faster than the mantle and crust from west to east from the early 1970s until around 2009. But from 2009 to 2011, the rotation seemed to pause. Since then, the rotation appears to be gradually reversing. And soon, if we could look down to the core, it might seem to be rotating in the opposite direction to us. However, this is not an event where the Earth will stop. Instead, the inner core is now more synchronized with the rest of the planet compared to a decade ago when it was rotating slightly faster. This is normal and not a cause for concern. Therefore, we do not need to worry too much about that event. Thank you for watching the video.